Okay, so to apply everything that we've seen so far in concatenation, we would like to do this little exercise. Okay, the exercise consists of using matrices A, B, and C in order to form matrix D and E. Okay, we want to use only matrix A, B, and C to form matrices D and E. Okay, so for that, let's go back to our MATLAB. We need a way of seeing these two screens at the same time, okay, so that we can follow. So I'll take advantage of that to show you a flexibility that you can have with the interface of MATLAB. Okay, so we can send this command window out of this interface in order to have it isolated on a particular side. Okay, so to do that, I can click right here and then undock it. Okay, so if I undock that, you see that the window is taken out, okay, and what you have is what is left. You have the workspace this way, command window, and the command window itself has been taken out, right? So we can bring it out this way because this is where we are writing all our commands and where we want to see our results, okay? So, and then let me just put the word here by the side so that we have our exercise on this side that I can also like that, okay? And we have our command window here. So let's start by creating the matrices that we need, right? So we'll need A. A is equal to 1:3, as you can see, right? 1, 2, 3. We'll need B, which will be equal to 4, 5, 4:5, comma 6:7. No, I could just write 6, comma 7. It makes no difference, right? And then C is equal to 8:9. I don't just want to write the square bracket. Okay, so that's what we have. Our matrices are now well created. Now look at this D. We want to form D using only A, B, and C. Okay, for that we'll need to locate exactly where A is found, where B is found, and where C is found in the matrix D. Right? So we have A right down here. Are you seeing that? This is our A. Our B, this is it here. We have our B here, and we have our C this way, but our C has been transposed, right? So it's instead a column vector instead of a row vector. So we just need to use C transpose there. Good. So what do we see? Okay, if we separate these into these various sections, we see that let me enter here. We see that this part here will be a block, okay, and then this other part will be another block. These two matrices are horizontally concatenated, and then all of that block above is vertically concatenated with A that we have down here. Okay, so how do we do that to form D? What we are saying with D, we open our square brackets first to form the matrix. We say the first part of D is B, right? We have B first. Sorry about that. We have B first, right? Then C transpose is horizontally concatenated to D, to B rather, right? It is on the left of B. So we'll say comma C transpose, okay? And then all of this is vertically concatenated to A, right? So it means A is under all of this. So to go under, we'll just say semicolon and then capital A. And that should, whoa, what happened? It's an error using horizontal concatenation. Dimensions of arrays being concatenated are not consistent. Okay, so let's check that out. Okay, I'm happy we had that error. If I have B, oh, my B is not my B. What did I say about B here? What happened? 4, 5, semicolon. How did I create B? Okay, I put comma instead of semicolon. I did not see that. Good. So let's try that again. Okay, perfect. So we have 4, 6, 5, 7, then 8, 9, 1, 2, 3. As simple as that, right? So what about exercise 2? Again, we need to locate where these matrices are found inside here, right? So we see that it starts by 1, 2, 3. So this is A transpose right here. Okay. And then we have 4, 5, 6, 7. Strange, because here we have 4, 5, 6, 7. So the matrix B is not completely found right here. It is found in parts. So it means we will need to do what? We will need to index, right? So that we have what we need. So we have 4, 5 here, okay, and then 6, 7 here. We will really need to index the matrix B to have what we want, okay. And then here we have 7, here we have 8, 9. 8, 9 here is C transpose. So let's do that. I will have E to be equal to, if we go horizontally concatenate each one, right, knowing how we index, then everything should be just fine, okay. Good. So this will be equal to, we'll have A transpose first, right? A dot transpose, okay? Then comma, because this one comes next, okay? And in the comma, I have B what? B of 1, right? Are you seeing that we need to index the whole of the first row of B? So it is B of 1, comma, column, right? And then we'll need to transpose that for it to be horizontal, right? But then this B now is, as you can see here, vertically concatenated with 6 right here, okay? Are you seeing that? So it means we'll need to do a semicolon here, and then a semicolon here, and then say B of 6 here is at row 2 and column 1, right? So we'll say B of 2 comma 1. So but there will be a problem here, right? The problem in the sense that when you put semicolon here, it is all of the matrix that goes down, okay? So it will try to put this B of 2 comma 1 under this A, right? So we don't want that. We want this B of 2 comma 1 to be under this B of 1 here. So what we'll do is that we'll put another square bracket here to indicate that it is another uh, internal concatenation on its own, okay, before continuing with the comma, so that it can finish creating this matrix, okay, before doing the comma and then creating the last one. And even in the last one, as sense, will have the same type of concatenation, okay. So here for 7 it is B of 2 comma 2, right? So I just want to say B of, I can use a unique index in there, right? 1, 2, 3, 4, right? I can say 4. Just like here, I could say 1, 2, right? I can say B of 2 here. Let's just say B of 2. And here B of 4. And all these concepts I'm using now, we've seen it in the previous tutorials, right? So I'm not using anything foreign, okay? I mean for indexing. So what is left is just to vertically concatenate this, right? So semicolon, because C transpose is under that. C dot transpose. And if we press enter, we should have our beautiful matrix, right? 1, 2, 3, 4, 5, 6, 7, 8, 9. All right. So I hope that this gives you a little bit of understanding of how matrices can be combined in both directions, okay, to form larger matrices. Okay, so see you in the next lesson to be able to close this section on concatenation.